OH. Alright? You start with the carbonyl. The carbonyl is going to be the guy over in the corner over there. If there happens to be a carbon above it, then you worry about it hanging up or down. If there's no carbon, you don't worry about it. Alright? So this is carbons 1, 2, 3, and 4. Alright? Now, so number 2 is still, which way, up or down? 3, down, 4, or it's in the ring, it's the ring one. And so what do we do with 5 and 6? We throw them away. No, we just stick them up here. Put them the way they were. So 5 and 6. So we got 2 guys left over on that side. Don't throw away the leftovers. Do not rearrange the carbon schedule. Do not rearrange where the carbonyl is. You know, as much as you might want to. Some of you have evil minds. Okay? Do not rearrange where the carbonyl is. If it's the first carbon, carbon number 1 is in the corner. If it's the second carbon, carbon number 2 is in the corner. We don't have to worry about anywhere it's carbon number 3. Alright? So yes, you can have more than one carbon left over. Which I think answers your question.
Yeah.
Yeah.
Thank you.
Okay. Alright. Now can I do this? I have this burning desire to do number 9. Which was the name of a Beatles song once. And the whole song went number 9, number 9, number 9, number 9. Don't stop. That's the way the whole song went. They were obviously, they'd ingested something. Okay. Alright, so this is number 9. We're doing enzyme kinetics. This is 1 over B. This is 1 over S. This is the enzyme alone. And the key word there, which is in all caps, is competitive inhibitor. Competitive inhibitors affect what? Kcat or Km? Km. Which means, which are we going to screw with? This or this? The x-axis. This is what we're messing with. Okay. So any of the answers that change the y-intercept, you ignore. Any of the answers that change the y-intercept, you automatically throw them out. So that rules out answers C and A. Just screw them. They're not there. So the ones you have to worry about are D and E. And B. Okay? Now, B, you're not going to be. Okay? What we're wanting, an inhibitor is something that is going to push the intercept closer to the the axis, right? With an inhibitor, we're going to go that way. That's why B goes out the window. So B goes bye-bye. Okay? Next thing is, the better the inhibitor, the closer to the axis you get. So which one's closer? E. Because 1100 would be closer to the axis than 1600. Remember, the idea is, the closer to the axis, the bigger Km would be. The apparent Km would be. And the bigger Km, the worse this thing is. Bigger Km is, badder. The worse things are. It's big is bad here. Okay. Number 10. We're not going to make anybody actually extrapolate numbers from a curve in the class because we don't even hurt themselves or anybody else with a ruler. I know a couple of you would be candidates. We're going to make some people take the exam in crayon. Okay. T1, so I've actually given you all the data. T1 is 35 degrees, T2 is 65 degrees. What's the first thing you're going to do to those numbers? You're going to Kelvinize them, right? So this goes to 308, And this goes to 338. All right, now, we said it was 15% melted here. If it's 15% melted, what's the rest of it? Okay, the rest of it's 85%, yes. But what is it? It's unmelted. It melted, it has a T in it. So the K there, the first K there is 15 over 85. Don't forget the other part. Okay? Well, you know one of the wrong answers is the one where you just took the log of 15. You know one of the wrong answers is one where you use K being 15. Right? I can guarantee there's a wrong. That's how I came up with one of the wrong answers. But you got melted over the unmelted, so it's going to be whatever this is over that. Just like the other one, this was 60. So what's this? 40. So the K here is 60 over 40. It's not 60. It's not 0.6. Okay? So then we use our cute little equation. Log of K2 over K1 is equal to minus delta H over R times T1 minus T2 over T1 times T2. Okay? And we go and we crank through this baby, plugging in the T's and the K's. What do we use for R? 8.31. Now, do not use the gas version, the 0.0821. There's a wrong answer where that gets used. I think there was. All right, so we try to do all that, and the answer comes out to B, 61.8 kilojoules per mole. Depending upon your calculator, you might have gotten something slightly different from that if you actually did the calculation. I did this morning, it got 61.4. So it sort of depends upon how you round things off. Okay? Now, one of the key things is you'll notice that what I'm going to stress here is you should get a K, if you're doing if you do something like this, you should get a K somewhere in this range. You should get a K of 30, 40, 50, 60, 70, 80. You should not get a K that's a fraction, like 0.5. You should not get a K that's 4, probably. You shouldn't get one that, on the other hand, is 500 zillion. Okay? Which is equal to the number of barrels of oil. Okay. And you also should get, if you're melting something, what should be the sign on the K? Positive, right? Because you're melting it. Because that means you're adding heat. Right? Everybody over here in the quiet side, you agree with that? Okay. All right, we'll go over to you guys now. See, the reason I walk around on that side of the room is I don't walk into things as much, in case you were curious. If I walked around over here, I keep bumping into this and give you comic relief. All right, but I'll stand over here for now. All right, which of these statements is true? Allosteric enzyme inhibitors increase the apparent Km.
15 or 85?
No, allosteric inhibitors work on Kcat. They work on Kcat, not Km. Okay? They're non-competitive inhibitors. Non-competitive inhibitors block the binding of the substrate. No, they have their own separate little hole that they worm their way into. Slide their way into. Whatever. Okay. Competitive enzyme inhibitors bind to the substrate, preventing its binding to the enzyme. Well, that's just total bullshit. Inhibitors bind to the enzyme, not to the substrate. So that rules that out. Allosteric inhibitors decrease the apparent Kcat. You might want to vote for that. Yes? Yeah, they're going to decrease the Kcat. They're going to make it look like it's working worse. It's an inhibitor. D is the correct answer. Competitive enzyme inhibitors decrease the apparent Km. No, it says decrease here, right? What do? They increase the Km.